This is Mr. Martin in Earth-Space Science with another lecture on plate tectonics. So far in our study of plate tectonics, we have learned that the Earth's lithosphere is broken into large plates which move and slide against one another. We also found evidence which points to our confidence all belonging to one large continent named Pangaea. In this lecture, we will explore the two distinct views of how long it took for this continental movement to occur. Before we begin in our study, we need to understand a new term. It's called uniformitarian. It's the belief that rates of change or conditions we see in today's Earth have always been that same in the past. For instance, if you see something moving at 1 mile an hour, based on this view, you would have to assume it has always moved at 1 mile an hour. Today, the measured rates of plate movements vary from less than a centimeter per year up to more than 50 centimeters per year in different directions as they push and tug against one another. Based on those observed rates today, uniformitarian geologists estimate that Pangaea broke up about 200 million years ago as they wind the clock backwards to see where these continents come together and how long it takes at today's current rates. One problem with an old Earth estimate is that the modern erosion rates, the rate at which wind and rain wear down mountains, exceeds the rate of mountain building and how much mountains are built up by a fairly significant amount. Based on that conclusion, and except where mountains are still growing, most mountains should have eroded to sea level long ago. Taking all this in, creationary geologists agree with uniformitarians. There is ample geologic evidence for tectonic plates, movement and shifting across the surface of the Earth, subduction where one plate slides underneath another, the existence of mountains where plates buckle and push up, and other features that seem to be associated also with plate tectonics. So far we've seen where both sides, creation and evolution, or uniformitarian, agree on certain aspects. Now we're going to see where they disagree. They disagree on the time frame, the overall span of time, the rate, the overall lapse of movement within a given time frame, and the underlying processes that produced our modern day continents. If you look at the picture on the lower right, you'll see what looks like a starting line. You see the proverbial tortoise and the hare, one going extremely slow but getting there eventually, and the other going fairly quick and rapid. That is pretty much an analogy between the creationary and the evolution or uniformitarian views, a tortoise and a hare. Taking the angle of the hare would be considered what creationists call the runaway subduction, or involves a rapid slipping of oceanic crust under plates moving at speeds many kilometers per hour rather than just the few centimeters per year that we observe today. The result of this rapid shifting of continental and oceanic plates would be exactly the way it is described in the name, as catastrophic plate tectonics. There is some evidence for this rapid slipping of crust underneath and subducting underneath other plates. Images of the mantle obtained from analysis of earthquake data indicate immense cooler masses at a greater depth within the mantle, which may be remnants of the subducted ocean crust that has not yet melted. Again, the result of catastrophic plate tectonics would be the whole physical arrangement of the Earth was disrupted and changed in a short period of time as the continents spread apart, and this again is called catastrophic plate tectonics. Always raises the question about what does the Bible say, and can we find evidence of Pangaea in the Bible? Keeping in mind that the Bible itself is not a science textbook, but a communication from a loving, merciful God to his people, that if you look in Genesis 1, 9 through 10, and God said, "Let the water under the sky be gathered to one place, and let the dry ground appear. And it was so. God called the dry ground land, and the gathered waters he called seas. And God saw that it was good." Here's an example or an illustration of what Pangaea might have looked like when it started to break up. You can start to see the continent of Africa kind of breaking up and moving. If you look on the lower right hand corner, you'll see two objects. One is the Madagascar, the island of Madagascar, and the second, now just starting to move out along the side, would be the continent of India as it's rapidly moving up the what would become the Indian Ocean, eventually slamming into the Eurasian plate. You also notice what's happening as different parts of Europe are starting to get uplifted, moving up above what would be coastal water areas, turning into dry ground. Here's another illustration from the Western Hemisphere. You can see now you've got Africa and South America tied together. As North America starts to move out west, you notice the great inland sea opening up where Colorado and Kansas and Missouri would be now. You can see the ancestral Rocky Mountains, as well as they move farther apart. What happens is that uplift then causes the waters themselves to disperse and to move back into the oceans as the continents take on a shape closer to what we would consider the positions of the continents today. Thanks for joining me as we explored the two views of plate tectonics.